Welcome to a lesson with Dr. Powell. Let's take a look at this equation of an ellipse. Now, just like the equation of a circle sometimes is not written in standard form, the equation of an ellipse doesn't have to be either. Now, how can we be sure that this is the equation of ellipse? Well, let's take a look at the coefficients of x squared and y squared. Notice how they both share the exact same sign. That tells us that we have an ellipse going on right here. Okay, so let's get going. We tackle it the same way as we would for a circle. Let's collect our x terms. 25x squared and the minus 100x. Let's collect the y's together. 4y squared plus 8y. And then this 4, let's put on the other side, so negative 4. Okay, next, what we do is we would like the coefficient of x squared to be 1, so we factor out the 25. And we'll put a bracket here. So we'll be left with x squared minus 4x. All right, and then over here we do the same thing, 4, and we make a bracket. Y squared plus 2y, another bracket, negative 4. The reason why I made these brackets, you'll see why. We're going to complete the square, but we're going to complete it inside of the brackets as if the brackets were its own universe here. So continuing on, x squared minus 4x is replaceable with x minus 2 quantity squared. But in order to make that replacement, we've added something. We've added 4. Which is negative 2 squared. Because if you expand and multiply this out, you'll get x squared minus 4x plus 4. So this is plus 4 more than what we had here when we made this replacement. So to offset that replacement, we subtract 4. What goes here is always a negative. It's simply this guy squared and make sure you have a negative over here. So negative 2 squared, but then make it negative. And that lives, remember, in the brackets. Don't forget to make sure it lives in the brackets there, including the square. We repeat over here, doing the same thing. Y squared plus 2y is replaceable with y plus 1, where we took 1/2 of that 2, just like we take that 1/2 of that negative 4. All right, now making this replacement, we've added a 1, which is just like that 1 squared, so we have to offset it by subtracting a 1, keep it in the brackets. Okay. Now we're set. Now we distribute this 25 into both parts here, and this 4 into both parts here. Okay, so we have 25x minus 2 quantity squared minus 100. Here we have plus 4y plus 1 quantity squared minus 4, and that's equal to negative 4. Okay. Now notice that we have a negative 4 on both sides. If we add 4 to both sides, that just goes away. Now we can add 100 to both sides. And so we're left with 100 on this side. And over here we have 25x minus 2 quantity squared plus 4y plus 1 quantity squared. Now let's remember what our goal is. Standard form for an ellipse will have a 1 on one side. So for instance, let's take a look at that, what we're after. We would like this to look something like the square over a number plus square over a number, where we have like an x, we have a y, and we have equal to 1. This is standard form for an ellipse, and then we know how to graph it from here. But right now, currently, so this is the goal, this is what we're after. But right now, currently, we have 25 quantity x minus 2 squared plus 4y plus 1 squared is equal to 100. So how do we move from here to here? Notice we have 1 on this side. What we do is we divide everything by whatever we have over here. So 100 in this case, divide by 100. All right, so this now becomes a 1. Now on this side, let's think. We just reduce our fractions. 1, 25. So we have y plus 1 squared over 25. Over here, we do something similar. Let's see, 1 and 4. So we have x minus 2 squared over 4. We have successfully rewritten the equation of the ellipse in standard form. Thanks for watching.